Hi everybody. Today I'm going to cover the second part in our project of upgrading the 5-volt reference standard that we made earlier to give us the additional voltages of 100 millivolts, 1 volt, 10 volts, as well as the original 5-volt reference we had. Now you may recall that on the first part of this upgrade project I covered the circuit design and the changes that we're making. I tested that out on a breadboard and showed how it could be easily calibrated. Now in this second part today I'm going to cover the final build of this project, where we manufacture the unit on its own printed circuit board here. Now this particular board I've made, I did a separate video on making printed circuit board, which happened to be this one, and I'll put the link down below. In addition to that, I'll add a separate link where you can download a PDF file that will have the artwork and the component layout drawings and the circuit diagram, which you can then use to make your own unit. So today we're going to finalize this project. I'll cover again the components that we're going to use. We'll build it onto the PCB. We'll then go through the calibration and we'll finally box the unit in a small black plastic project box. So first of all, let's have a quick look at the components we're going to be using today, in particular the ICs, because I've decided to use all small SMD ICs and solder them on the print side of the board, and I'll go through that process with you. So let's get started. Right, here we see all the components we're using for the project today. The printed circuit board that I showed you a little earlier. There's the rotary switch, which is a 3-pole 4-way switch, and we have the 4 banana sockets. I've chosen a red and a black and a yellow one. There I have a pointer knob for the switching. There's the MOSFET. There's the NPN transistor, the 2N3904. And these resistors here, the black ones, they're all 0.1% tolerance, good quality resistors these, so I've got a couple of 100k there. There's the 90.9k. Instead of the 6.2k's I'm using precision 6.19k, and there's the 9.09k. The other resistors, there's a 1 megohm 0.1% resistor. But the other resistors here, where we have 5 1k and we have 1 10 meg, they're just 1% tolerance. There you see the multi-turn presets we'll be using in the divider network. There's the dual LED, the red-green dual LED, the tactile switch, the diodes here. There's the 1N4001, and we have a couple of 5.6 volt Zeners. The tantalum capacitors you see here, these are for 1 microfarad, and then we have a 10 microfarad tantalum and a little 10 microfarad electrolytic there. There's two 220 microhenry chokes there we're using, and that's going to be used in the plus and minus 15 volt supply rails. And here you can see the small ICs. Now I'm using SMD ICs, so I can solder these directly onto the copper side of the board. So we have the 5-volt reference IC there, the ISL 21009. There is the voltage converter IC, which is the LT1026, and there we have the precision differential amplifier IC, which is the INA 105. Now, in addition to all of that, you can see here I've got 4 of these links, these pins here, which I'll be using as the links in the Hammond divider network we have, and a couple of shorting plugs which we'll use temporarily to do the calibration. So there's all the components for the project today, and I think the next thing we'll do now is we'll look at how we're going to solder these ICs onto the printed circuit board. Right, here we have the printed circuit board we're going to use now today, and basically what I've done here is I've designed the print so we can solder the surface mount ICs on the printed circuit side of the board, and all the other components will be fitted on the other side of the board through the holes. So you can see here there's one IC there, you have one there, and you have the other one over here. Well, let me just zoom a little bit closer and just show you where the integrated circuits are going to go on the printed circuit board, and I'll just point out their orientation. Right, here we have a closer look at the area of the board where the integrated circuits are going, soldered on the board itself. This area here is for the 5V reference IC, the ISL 21009, and you'll notice I put a little round dot there which identifies pin 1, so that's next to pin 1, so pin 1 is there just next to it. And then below this IC, in this area here, between the IC and the rotary switch there, we have the INA 105 chip, the differential amplifier chip. And again, if you look carefully, you'll see that I have a little round dot just there, and just below that is pin 1. So the dot signifies the area where pin 1 would just go to, just below it. And then finally the third IC here, which is the voltage converter IC, is in this area of the board here. So there's all the pads there and there. And again, a little dot there on the printed circuit board, which is identifying once again pin 1 just below it. So I think what we'll do next is we'll solder the surface mount ICs on the board. So let's have a look at that. Right, the first IC we're going to solder on the board is the 5V reference IC, this little one here, and make sure you get it correctly orientated for pin 1. You'll notice on the IC itself pin 1 is signified by a little circular indentation next to that pin. Right, the first thing I'm going to do is just put a little bit of flux on the pins of the IC with a flux pen, just rub a flux pen on the IC. And then I'm going to position it on the board. Once you have the IC positioned on the board, just press it down firmly so the flux helps to hold it in place, and then I'm going to just tack one corner. So what I'm going to do is just put some solder on that pin there, the free pin, just to hold the IC in place. So let's do that first. Right, well, once we've got one corner soldered, the IC is now being firmly held in place, so we can now solder the other pins. So we can see now the IC is now firmly soldered in place, and you probably can see there that the little dot on the PCB identifying pin 1, and on the chip itself you've got the little round indentation on the IC corresponding to that pin 1. So let's now solder the other ICs in the same way. Here we now have all the ICs soldered in place on the board. When you're doing this, make absolutely sure you have the orientation for pin 1 correct. On some of the ICs you'll find there's a little round indentation identifying pin 1, and on the others sometimes it's a little bit more subtle, where down one side of the IC there you find the edge of that is chamfered, and that's the top corner there where pin 1 is, and the same with this one here. It's got like a chamfered edge down that side, the other side's straight, that side's got like a chamfered edge, and pin 1 is in that far corner there. So the next thing I'll do is we'll have a look at soldering on the components around the voltage converter IC. And here's the overview of the other side of the board now. So we're going to solder on the capacitors in this area here, which relate to the voltage converter IC, and also the diode, the 1N4001, which is feeding the supply voltage to it. So let me solder them in place and we'll have another look. Right, here you can now see I've soldered the 4 capacitors and the diode associated with the voltage converter IC. This is a component layout for the printed circuit board, so these are the capacitors here that I've installed in that diode. Now you need to be careful when you put the tantalum capacitor in that you connect them the correct way. The positive pin on this layout here is this square pin there, so they're all the positive pins, and the diode obviously is the little band across there is the cathode going to that side. The next thing we'll do now is we'll install the MOSFET, the input circuitry there supplying the voltage, and the 9-volt power leads there. So let me put those components in place, solder them in, and we'll come back and have another look. Right, here we now have the input power switching circuitry here. I've got the MOSFETs, the 10 megohm resistor, the 10 microfarad capacitor there. I put in the little tactile push switch there, and it's 1K associated resistor, and I've got the input lead for the 9-volt battery also wired in. So I think the next thing we'll do is we'll put in the circuitry to do with the battery monitor circuitry around here. I also put in a little pin here which is a grounding pin. Installed all the components there around the sort of battery monitor circuitry there. There's the transistor, the 2N3904, the dual LED, the resistors in place now, and the 2 Zener diodes there. So I think at this stage now, before we install any more components, we can do a test to check the actual 5-volt reference coming out, because we have the power supply installed and the switching circuit there, so we can test the 5-volt reference on the yellow socket. So I've installed the sockets temporary there so we can do some tests. Now the next thing I think we'll do is just test the 5-volt reference coming out of the unit. So I've got the little multimeter connected to the 5-volt reference out, which is the yellow banana socket there, and ground. So if I just connect a 9-volt battery, and if I then trigger it by pressing the button, and I think there clearly you can see we've got exactly 5 volts coming out. So that seems to be working fine, and the LED is showing green. We'll just see if the LED goes out to red. As you can see there, the LED is now gone red, the power is switching off, and the voltage is dropping down. So that seems to be all working correctly. So we know that the power supply is working fine and the 5-volt reference is working fine. So I think what I'll do next is I'll just test the output from the voltage converter IC and make sure we have the plus and minus 15 volts coming out. I've just turned the board round, and I've got the negative lead of the meter on the ground connection there. So I'm now going to test there's the voltage converter IC, and we can test the outputs there and there. So let me just trigger the circuit. And we'll test this one here first. And there you can see we have our 15 volts positive coming out. And then this one here. And we have our negative 15 volts coming out. So that seems fine. Right, I think the next thing we'll do now is we'll install the other components. Right, here we have the completed board now. I have all the components installed. There's the divider network at that side and the two trim ports there for calibration. So what I'll do now, I'll just test the unit. It's not been calibrated yet, but I'll just test the units and see what readings we get out. So let's trigger it on. It's switched at the moment to the 10 volt range. That's what it's reading, 10 volts. I'll switch it now to the 5 volt range. 5 volts. Go to the 1 volt range. The 1 volt range there is slightly out of calibration, but we'll come back and calibrate the unit. Let's just go to the 100 millivolt range. It's just a fraction over 100 millivolts, so again that needs calibrating. But the unit seems to be working fine, so I think the next thing is to calibrate the unit. It's powered itself down now. I've just got the unit connected to the Keithley meter here, so let me just plug the battery in. There we go, and I'll just switch on. At the moment it's switched to the 10 volt range, and there we can see we've got 10.3050, so that's pretty good actually. Let's switch to the 5 volt range. That's 5.3037. Let me just move the positive lead now to directly from the 5 volt reference chip. So I think you'll see there that it's pretty accurate whichever one you use. Just a fraction different on the switched one. And then the 1 volt needs to be calibrated, and the 100 millivolts also needs to be calibrated. So let's first of all calibrate the 1 volt range. To calibrate the unit, I've put the two short-in links in here to calibrate the 1 volt reference out, and that's the preset we'll adjust to do the calibration. First thing I need to do is check the 10 volts output, make a note of that, and then switch it to the 1 volt range and adjust that preset to give me exactly half of what the 10 volt reading was. So let's switch on. So the 10 volt reading is reading 10.304546, about 10.305, so half of that will be 5.3025 or 26. So flick it to the 1 volt range, and then we adjust this to 5.025 thereabouts. So that round about there. So now if I remove the two links, we should get exactly 1 volt. Well, that's pretty close actually, 1.3016. So I'm happy with that. So the next thing we'll do now is check the calibration of the 100 millivolt range. To calibrate the 100 millivolt range now, I've put the two short-in links in these two points here, and we're going to adjust that preset there for the 100 millivolt calibration. And this time we're going to set it again to half of the 10 volts, which we noted before, which was 5.3026. But this time we're going to connect the positive lead of the meter to the 100 millivolt calibration point, which is just there. There's a pin there. So I'm going to remove the lead and then just clip onto it there like that. So that's set now to 100 millivolts. I have the positive of the meter lead going to the calibration point for the 100 millivolt calibration setting, and I'm now going to switch on and trim the preset and try and get half of that 10 volt reference that we had. So let's switch on. So it's reading low, that. So let's see what we can do now and try and trim that. It's coming up. Try and get it to... Right, that's as far as I can get it. So obviously I can't trim this sufficiently to get me into calibration, and at the moment the trimmer is at the minimum setting. So the fact that we can't trim this down with the preset, it would mean that the resistor there, that we have that 1 meg resistor which is in series with the preset, that 1 meg is too high, so we need to reduce that. Right, I've reduced the 1 meg resistor there now to 910k, and if I switch on again and see whether we can now adjust that to the 5 volts. There we are, just about there. Right, let me just remove those links. I've removed the links. Let me just change the meter lead now and connect it to the input terminal there. And they were reading, well, thereabouts 100 millivolts there, as you see. The power's gone off. I'll just switch it on again. Yep, so that looks fine. 100 millivolts, that looks fine. So let's switch down again. 1 volt, 5 volts, 10 volts. That seems okay. Well, here we have the project box I propose using today. A little black plastic project box. It's ideal for this purpose. It's 150 millimeters in height, and it's 100 millimeters across, and the depth of it is 60, a little bit deeper than what we need, but it probably serve our purposes okay. And the lid just is screwed on there, so my intention is to fix the unit on the lid side here, so then we can just screw it back onto the box housing there. Right, well, the other thing I've done, I've made myself a front fascia which can be stuck on the front of the unit, and I've done it on a sort of it's self-adhesive, peel back the back, and it's self-adhesive paper with a glossy front, and just printed this on my inkjet printer. Well, I think the easiest way to drill the holes in the lid there is to use the front fascia as a template, and that just slots into the recess there on the lid, so we can position it correctly, and then simply mark the holes, prick the holes through, and then we can drill them, and we've got them in the centre then. So let me go away and do that. Right, here now, see, I've drilled all the holes on the front fascia there, so that's ready for mounting the unit. I have a small little knob here that fits through the back for the tactile switch, so basically that fits through and it protrudes through the front panel there, then pushes onto the tactile switch there. So the next thing to do really is to stick on the front fascia, cut through the holes, and then remove the banana sockets from the board and mount them on here, and then assemble the unit to the back. Also, I'll have to just unsolder the LED so I can then let it sit correctly in place before I solder all the leads on permanently. So let's now stick on the front fascia. Right, here we have the fascia now stuck onto the front panel. I found the easy way to do that was to hold the whole panel up towards the light, and then you can see the holes coming through where the crosses are. You can see the light shining through, so it helps you align them up. So the next thing I'll do now is I'll just cut out the holes. Right, there we have all the holes now cut through. So the next thing I'm going to do is mount the banana sockets there. Well, here we have the panel installed behind the front fascia there. All the banana sockets at the front there, the LED coming through, and the push on button. The whole unit is held in place with the nut on the rotary switch there, which is quite nice. So there's the printed circuit board. It's held in place with that rotary switch nut. And the only thing we need to do on the back now is to solder the banana socket input connections onto the printed circuit. So that fits quite nicely, and you still have access there to the calibration settings. The only thing I did think of afterwards is that to put the shorting links on again, you have to remove it from the front cover. So maybe one modification I would make is to solder the connections for the links on the printed circuit side of the board. So what I'll do next is I will solder the connections here onto the printed circuit board. Well, there you have the unit now assembled. I've cut the spindle down so the pointer knob now fits on quite nicely. So I think what we'll do now is we'll fit it in its plastic box and give it a final test. What I've also decided to do is I put a different battery holder on, which I can then fix on the bottom of the box. Right, we'll give the unit a final test. It's all boxed up now, so let's press the button and look at the readings on the meter. It's on the 10 volt range at the moment. So there you are, it's 10.3045 or thereabouts, so certainly to the 3 decimal places it's 10 volts. So we'll go to the 5 volts, and the same there again with the 5 volts, certainly to 3 decimal places. The 1 volt, again, is correct now to 3 decimal places, and the 100 millivolts. That's reading 0.10001 of a volt. I'm pretty happy with that actually. Just one final test. I just want to compare the switched output from the 5 volt to the 5 volt reference coming straight from the reference IC. Just see if what the difference is there. So it's on the 5 volt switch now. So I'll press the button and just let's have a look at the switched output of the 5 volts. And that's reading 5.303 thereabouts, and on the directly from the IC it's 5.3019. Just a very slight difference. The directly from the IC obviously is a little bit more accurate, but I think you'll agree that they're both correct to 3 decimal places. So 10 volts, 5, 1 volt and 100 millivolts. Well, that works well, and after about 2 minutes the unit powers itself down. And as you see, the red light comes on as it powers down. Well, here's a copy now of the final circuit diagram for our project today. Basically what we discussed previously in part 1, with the addition of some extra filtering on the plus and minus 15 volt supply here to the INA 105 chip. So I've got a couple of inductors there, 220 microhenry on the plus 15 volt supply and on the minus 15 volt supply, and then a couple of little filter capacitors, also a 0.1 there and a 0.1 there on the supply inputs to that IC. Now the other thing that we changed is in the Hammond divider network we found that to get the calibration correct on the 100 millivolt range we had to change the 1 megohm resistor there to a 910K, and other than that I think the circuit was exactly as we discussed previously. But I will make this circuit available as a download in a PDF file, which you can, I'll put the link down below, and I may even get a chance to just change that 1 megohm resistor to indicate it's a 910K, but you may have to play around with that circuitry there on the 100 millivolt range if you find you can't trim it correctly. But other than that, everything's working fine. Well, I hope you found that project on the upgrade of this voltage reference standard of interest. I will make the circuit diagram, the printed circuit board layout and the component layout available as a couple of PDF files, which I'll put down below, and you can download that and use it in your own project. If you found this useful, please give me a thumbs up, and I'll see you all again next time. Bye for now.